Hello everyone, welcome to IIT and Gate classes. This is lecture 15 on TOC, and in this lecture we are going to start PDA. Okay, actually I have started PDA in the last lecture itself, that is lecture 14, and I have given you basic introduction about PDA, and we have solved two questions on PDA. First question was L a power n b power n is greater than equal to 1, and I have constructed PDA by null store. And second question was a power n b power n is greater than equal to 1. Same language, okay, same question, but we have constructed PDA by final state. Okay, I have shown you these two questions, and in the last class itself I have given you homework that try to accept or reject these strings, these three strings by this PDA. Okay, so let me do it for you, and then we will jump to next questions. Okay, so see here carefully. See, AAA, triple B, that will be obviously accepted by this PDA, and I have already shown you, but let me give you a small idea here again. Okay, so for AAA, triple B, what I will say that we have a tape, okay, of infinite length divided into cells and so on. So I'm not repeating that thing again and again. We have AAA and triple B. Okay, now we have a read head. One end of the read head is connected with the tape, while other end is connected with the finite state control mechanism, which is storing the initial state, that is Q0. And we have a stack of infinite memory, and initially we have Z0. Okay, so we will apply the move. See here, Q0 A Z0. So see here, Q0 A Z0. Then we will push A Z0 in the stack, and we will remain on Q0 only. Okay, so let me do it roughly. So A will be pushed onto the stack. Next A will be again pushed onto the stack. Next A will be pushed onto the stack. That is again, see here, we are pushing all the A's, we are pushing. As soon as B come, then we will do cutting, and we will move to Q1 state. So B came, and then we will do cutting. We will move to state number Q1. On Q1 itself, BA cutting. Then again on Q1 itself, BA cutting. And then we are here. Okay, what exactly is here? We do not know. Okay, let me do it properly for you. Okay, so see here. Okay, so see here. Okay, what exactly is here? We do not know, and really we are not concerned about this thing. Okay, but we are here. That's it. This is confirmed that read head is here. Now it will not read anything from the tape. It will simply say that we are in the state Q1. See here, move carefully. We are in the Q1, and we have read Z0 from the stack. As soon as we have read Z0 from the stack, we will not read, PDA will not read anything from the tape. That means it will be a null move. Z0 will be pushed onto the stack, and state will be Q2. So finally we will be at Q2. Okay, so and see here carefully, starting from initial state. Now apply the definition. Starting from initial state, after reading entire input string, PDA is at one of the final state, hence string will be accepted. So AAA, triple B will be accepted. What about my 4A and triple B? See here carefully. What about my 4A, triple B? So 4 is and triple B. Let me do it with a different color so that you get proper idea. 4 is triple B. Okay, so what we are going to do here? So all the A's will be pushed onto the stack directly. We already know all these facts. So all these A will be pushed, and as soon as B come, we will do cutting. We are doing now cutting. Okay, now we have reached end of string, and still A is remaining in the stack. So we should have a move like we should have a move for say null move with A. Okay, so that means what? Whenever we are at Q1, we should read nothing from the tape and read A from the stack, and then we should move. We should go somewhere, but no move is here like that. Okay, so PDA will halt in dead configuration, and we will say that string is rejected. Okay, no doubt we have read the entire string, but we have not reached the final state because on Z0 we have a null move. Now on Q1, whenever Z0 is read from the stack, then we will read nothing from the tape and we will move to Q2. But here we are at Q1. Okay, whenever we reach here, see here. Okay, whenever we reach here, we are at Q1 only, and on Q1 we are reading A and we are reading nothing from the tape. Okay, so that means we should have a null move with A, which is not allowed, which is not in this PDA. So hence string will be rejected. So we have read the entire string. but still string is rejected because PDA is not halting in the final state, rather it is going to a dead configuration, and hence string will be rejected. Similarly, what about here? AAA 4Bs. See again, this is again very simple example. I hope you have already guessed it, but let me do it for you. AAA 4Bs. So by now you already know all these things, that we will push all the A's. So blindly we will push 4 A's in the stack, and as soon as B come, then we will do cutting. Okay, so we are doing cutting now. Okay, so triple A 4B. Na, sorry for that. I have given 3 A's. So let me do it again. Okay, let me do it properly. Triple A 4B's na. So this A should not be there. Okay, so see directly triple A na. All these A will be pushed onto the stack. Now as soon as B come, then we will do cutting. So for first B, we will cut this A. Okay, let me cut it again for you so that you do not get confused. See, this is cutting, this is again cutting, this is again cutting. Now we are at Q1 only. Now on Q1, we are reading Z0 from the stack. And as soon as we read Z0 from the stack, then we should apply a null move. See here, we should apply a null move. That means we should not read this B. Please see this carefully. Otherwise, it will trouble you a lot. Okay, please listen here carefully. Otherwise, it will trouble you a lot. Okay, so we are at Q1 and Z0 is read from the stack. So we will not read this B. We will not read this B, and state will be changed to Q2. Okay, so let me do it properly. So I will cut this Q1 and I will say that state is Q2. And how I have shown this, just because we have a move on Q1. On reading Z0 from the stack, we will read nothing from the tape, and Z0 will be pushed onto the stack. State will be Q2. So finally we are at Q2. But no doubt we are at final state, but we have not read this entire string. This B is left unread. Hence the string will be rejected. So why the string is rejected? Because string is not read entirely. Okay, I hope I have made the point clear to all of you. So please note it down all these things carefully. And now I will jump to the next slide. Okay, and we will see the next question. Please note it down carefully. Okay, so I'm jumping to next slide. Yeah, so next question is A power n, B power n is greater than equal to 0. Construct PDA accepting L by null store. Okay, we are constructing it by null store. Null store means there should be no final state. There should be no final state, and after reading entire string, stack should be empty. Then we will say that string is accepted, otherwise rejected. Okay, so let me do it on a faster pace because you already know all the facts related to this type of question. The only difference here and the previous question was, see here carefully, A power n, B power n is greater than equal to 1. Okay, but here we have done A power n, B power n is greater than equal to 0. Okay, so the same PDA will look like same. The only there will be a small difference only. Okay, so let me do it properly for you. Okay, so that you will be it's just like a revision for you. Okay, so let me do it properly. So on Q0 will be our initial state. Okay, as soon as you write A Z0 from the stack, you will push A onto the stack, that is A Z0. We will remain on Q0 only. A, then double A, that means we are pushing all the A's. As soon as B come and we have read A from the stack, we will push nothing onto the stack, that means cutting, and we will move to Q1. On Q1 itself, we will do B, A, null. That means what? We will cut all B's and A's. Okay, so B from the tape, A from the stack, we will do cutting. Okay, now after that, what we will say? We will say here null. Okay, so it's our own choice that you move to new state or do it here itself. So let me do it here itself. I will say that null Z0 null. Okay, so we have read nothing from the tape. As soon as we read, see again I'm repeating, on Q1, as soon as you read Z0 from the stack, then PDA will got excited. That is, it will be a null move, and we will read nothing from the tape, and nothing will be pushed onto the stack. That means stack will become empty. That's it. So this is your PDA for A power n, B power n is greater than equal to 1. Why this is for n is greater than equal to 1? Because you should read smallest string accepted will be AB. You can check it out from here itself. Okay, null won't be accepted. So smallest possible string will be AB. Okay, now see here, what should be done if we want to accept null also? So in that scenario, okay, I will say Q0 null Z0 null. You can move to new state. and you can move or you can have a self loop here itself, because we are not much concerned with states. Okay, so let me do it here itself. It hardly matters. Okay, but the only thing is we should try to make PDA with minimum states. Okay, so that's why I am removing it. Okay, so one way is you can move to new state, or another can be like here also, null z naught null, null z naught null. Okay, so now you can say null string will be also accepted, because null string accepted means what? On q naught, as soon as you take you read z naught from the stack, you will read nothing from the tape and stack will become empty. This is the case. Now see here carefully, on q naught, let me use a different color. On q naught, okay, as soon as you read z naught from the stack, we have two options. PDA may get excited and it will empty the stack, or PDA will not get excited, it will read A from the tape. So that means what? Non-determinism. So we have constructed NDPDA. Please note it down carefully. We have constructed NDPDA. Okay, but in the previous questions we were designing DPDA only. We were not construct. Obviously, if it is DPDA, it will be also NDPDA. So let me say it carefully that we have constructed DPDA. Okay, so here you already know by default PDA means NDPDA, but here we have constructed DPDA. You can check it carefully. Okay, so I have already told you unique moves. See here, unique moves, and if null move, then no true move. So here Q1 null Z naught. So Q1 Z naught combination, we have a null move. So Q1 Z naught, see here carefully, Q1 Z naught, there is no true move. So hence it was DPDA. Similarly here also you can check it out. Okay, so if see Q naught Z naught, we have a true move. Q naught a true move. So see where we have a null move, we have null move here only. So there should be no true move. So Q1 null Z naught Z naught. So Q1 Z naught combination, we have a null move. So see here Q1 Z naught, we do not have any true move. So this is first class DPDA. But this has become NDPDA because on Q naught we have a null move. Q naught null Z naught, that is null. Q naught on see on Q naught, after reading Z naught from the stack, PDA may get excited. It will read nothing from the tape and it will push nothing onto the stack. That means stack will become empty. So directly and indirectly we have to apply this move if we want to accept null string. Okay, but as soon as we apply this move, then there will be a problem. That means what? On Q naught Z naught, Q naught Z naught combination, we have a null move and we have a true move also. Hence it will become NDPDA. Okay, but and let me tell you one thing, that you won't be able to construct DPDA, you won't be able to construct DPDA with null store for this language. DPDA with null store for this language, for L. Okay, PDA with null store for L, not DPDA with null store for L, not possible. Please note it down carefully. Okay, so from this example we have concluded that DPDA, okay, DPDA with final state, okay, or let me say it after next slide. Okay, so DPDA with null store for L is not possible. Okay, let me show say this only. DPDA with null store for this for L is not possible. Okay, the same language we are going to construct PDA accepting L by final state. Okay, so see here carefully, the only difference in this question and this question was, here also we were doing by final state, but n was greater than equal to 1, and here we have n greater than equal to 0. Okay, so okay, so the only extra string is null now. So when can we say null is accepted by any PDA or FA? Initial should be final. So in case of FA also we said the same thing, that initial should be final, and in case of PDA also we are saying the same thing, that means initial should be final. Okay, so now I will say A Z naught, we will move to Q1, A double A. So we will keep on pushing the A's, that's it. So on Q1 we will keep on pushing the A's. As soon as B come, then we will do cutting, we will move to state Q2, and on Q2 we will say we will do all the cuttings, and after cutting that means whenever there is a confirmation that B's and A's are equal, so when we will get confirmation that on Q2 we write Z naught from the stack, as soon as we write Z naught from the stack, then we PDA will get excited, it will read nothing from the tape, and it will you can say push. It's our own choice because we are doing by final state. So stack may or may not be empty. So you can write here Z0 also, or you can write here null also. It's your own choice. We will move to Q3. That will be also our final state. So what exactly this PDA is doing? See here carefully. This is DPD or NDPDA. See here carefully. We have only one null move here. Okay, and on Q2 Z0, Q2 Z0 combination we have a null move, and Q2 Z0 combination we do not have any true move. Hence this is first class DPDA. Okay, so there should be no problem at all. And in the previous example, we have applied null move because we want to accept the null string. And here we do not need any null move because initial is final itself. So directly indirectly we will say that null string is accepted. So we and see here this is DPDA. I have already told you. So from this example we can conclude that DPDA with final state. Okay, let me show this by another color. DPDA by final state. Okay, DPDA by final state is more powerful than DPDA by null store. DPDA by null store. I'm writing roughly. I think you all are getting what I'm exactly trying to say here. Okay, so DPDA with final state is more powerful than DPDA by null stores. Okay, so we have two ways for acceptance. Now, I have already told you in the previous lecture itself, but I have given you with this example proof of the statement that there are some languages which can be accepted by DPDA by final state, but these cannot be accepted by DPDA by null store. So DPDA by final state is more powerful than DPDA by null store. Okay, I hope I have made the point clear. Let's move to next question. A power n b power to 1, n is greater than equal to 1. Construct PDA accepting L. Okay, so try to construct DPDA. If we are not able to construct it, then we will jump to NDPDA. Okay, so please do not think about it that we have written PDA, so we should construct NDPDA and so on. No, we should try to construct DPDA first. Okay, so let me do it for you. This is again very simple scenario. So what should be the logic? If logic is clear, then you can easily design PDA for it. Okay, so A power n, see here carefully, A power n, B power 2n. So what should you do? You should read A from tape, and push 2 A's on stack. Push 2 A's on stack. What will be the advantage? Advantage will be that whenever B will come, then we will do cutting directly. Okay, so the only thing in construction of PDA is that cutting should be very easy. Okay, so for making cutting easy, what we are doing is we are reading 1A and pushing 2 A's onto the stack. Okay, so I hope you have by now you have all imagined what exactly I am trying to say. Or if you are not able to imagine, then let me do it for you. See, we have double A and 4 B's. This string is in this language now. So how will you accept it? I will push these 2 A's. So first A, as soon as we read first A, we will push 2 A's onto the stack. And whenever we read this A, we will push 2 A's onto the stack. So now, obviously, we have 4 A's and here we have 4 B's. So directly we will do cutting. Okay, so there will be no problem at all. We can do it in this manner. Okay, so let me show you now properly how to design PDA. Okay, so if you are able to design, that means your concept is clear. So let me do it for you. So what I will say, I will start from initial state Q0. And the main aim of Q0 will be what? Pushing the A's. Okay, and as soon as it will read 1A, it will push 2 A's onto the stack. So let me do it properly. So Q0, on Q0, as soon as you read A from the tape and Z0 from the stack, what you are going to do, because Z0 was popped and popped before reading, so I will have to push this Z0 as well as this A will become 2A. Na? So I will push double A Z0 onto the stack. Now see here carefully, whenever A is read from the tape and A is read from the stack, then what we are going to do, this A which you have read from the stack, it is done by popping. Without popping, you have not read it. So first you have to pop it and then we can read it. So we have to make 2A for this A and this A, because we have popped, so we have to push it again. So I will push here 3 A's. This is very important point and trouble a lot of students. If you are not able to follow, please rewind the video and watch it again. Okay, so so now we have done we have fulfilled our condition for A's. Now we will see as soon as B come, we will read A from the stack. Okay, B from the tape, A from the stack. Then we will do cutting. Now that means we will push nothing onto the stack. We will move to Q1, and on Q1 our work is only cutting. That means B A null. And as soon as you read Z0 from the stack, you will read nothing from the tape. That means you will get excited, or PDA will get excited, and it will push Z0 or null, whatever you want. It will be pushed, and we will jump to final state, that is Q2. Okay, I hope I have made the point clear to all of you. Please note it down carefully, and we are jumping to the next question. Okay, or let me put everything on one slide so that you can note it down. Please note it down carefully. I'm jumping to next slide now. Okay, A power 2 and B power n and greater than equal to 1, construct PDA accepting value. So again, this is a different question from the previous scenario. So what should be the logic? What should be the logic here? Logic will be, see, let me do it properly. Example can be 4 A's and 2 B's. And I have already told you that cutting should be easy. Cutting should be easy. So for cutting should be easy, what should we do? Okay, Z0, initially we have Z0 onto the stack. Okay, so what will you do? You will push this A onto the stack. As soon as you read this A, you will push it onto the stack. And this A, you will, you can say leave it. Okay, you won't push it. So next A, you will push it onto the stack. And next day you will leave it. Now obviously see here we have 2 B's and 2 A's. Okay, so we will do cutting. So very easy task. So that's it. So logic should be what? First day will be pushed, second day should be ignored. Then next day should be pushed, then next day should be ignored, and so on. Okay, so if we have say 6 A's and 3 B's, so what will you do? You will push it and you will ignore it. Then you will push it, then you will ignore it, then you will push it, then you will ignore it. Okay, so see, the work is different now, so you have to take 2 different states. So Q0 will be pushing, Q1 will be ignoring. Q0 will be pushing, Q1 will be ignoring. Q0 will be pushing, Q1 will be ignoring. So now see here carefully, who will read the B? This is the good question, and this will trouble you a lot. Please listen it carefully. B will be read by Q0 only. Q1 cannot read B. Why Q1 cannot read B? If we are at Q1, that means what? We have read odd number of A's. Okay, but A power 2n means what? We have already said 2n. 2n means what? Even. So A should be even. A cannot be odd. So that means what? B should read Q0. Okay, sorry. Q0 should read B. Okay, Q0 should read B. Okay, so if Q1 read B, that means what? Number of A's are odd. How I am saying it? See here carefully. Okay, see here carefully. See, Q1 read A. That means what? Number of A's are odd. Q1 read this A. That means what? Number of A's are odd. See here carefully. We have 3 A's now. If Q1 read this A, that means what? Before this A, we have odd number of A's. Q1 read this A. That means what? Before this A, we have odd number of A's. That means 5 A's. If Q1 read A, that means what? Before that we have even number of A's. Okay, see here carefully. Q0 read this A. Before this we have even number of A's. That means 0. 0 is even. Q1 read this A. That means what? Before it we have even number of A's. See here carefully. Q0 read this A. That means what? Before it we have even number of A's. See here carefully. 4 A's and so on. So Q0 should read this B, na? Because we have even number of A's. I hope I have made the point clear to all of you. If you are not able to follow, please watch the rewind the video and watch it again. Okay. So now let me design PDA for you. Now everything is very easy. Okay. So what exactly PDA will look like? We have to do transitions between Q0, Q1, Q0, Q1, Q0, Q0, Q1. That's it. So let me do transitions. Okay. So initially we are at Q0. Okay. As soon as A is read, we will see Z0 from the stack, A from the tape. We will push A Z0. Okay, that means A as well as Z0 will be pushed onto the stack. Now next, we will jump to state Q1. What will be the aim of Q1? Q1 will ignore the A. That means what? Q1 will read A from the tape. Okay, Q0 will read A from the tape, and it will read A from the stack, and it will push A onto the stack itself. Why A is pushed onto the stack? Because A, which has read from the stack, that is done after popping. So we have popped this A, and after that we have read it. So we have to push that A, and the A which we have read from the tape should be ignored. Now next A should be pushed. So pushing work is done by Q naught. So I will write like this. Okay. So now I will say on Q1, as soon as you read A from the stack, sorry, A from the tape, A from the stack, then we will push A and we will jump to Q naught. Now work of Q naught will be what? Work of Q naught will be, it will push A. So A and double A. Okay, are you getting it? If you are not getting it, so let me trace example for you. 4 A's and 2 B's. First A, we are at Q naught now, and A is read. So what should be done? A should be pushed onto the stack. Okay, A as well as Z naught will be pushed onto the stack. Now next A. Okay, now we are at Q1. Q1 work will be to ignore this A. So what will you say? On Q1, we have read A from the tape and A from the stack. What should be done? The A, because we have done, we have read this A by popping. So we will see, we have read this A by popping. So we have to push it again. Okay, and this A will be ignored, and we will come back to Q naught itself. Now on Q naught, we have read this A and this A from the tape. Sorry, this A from the tape and this A from the stack. So what should be done? Both A should be pushed onto the stack. That means what? A after popping, we have to push it again, and the new A which I have read, we are going to push it. Okay, I hope I have made the point clear to all of you. So till now we have 2 A's. Now we will be at Q1 only. On Q1 we have read this A and this A. So see here on Q1, reading A from the tape, reading A from the stack. So this A will be ignored, and this A, because we have read it after popping, so we will push it again onto the stack. Okay, so now state will be changed to Q naught. Okay, so see here carefully, please try to follow this. Okay, we are just you can say jumping between these two states only. So B will be read by Q naught only. So I will write here like this. After reading B, A from the stack, we will push nothing onto the tape. We will push nothing onto the stack, and we will jump to new state Q2. So Q2, work of Q2 will be what? Cutting itself. So it will do cutting, B A null, B A null, B A null, and so on. It will do cutting, and after doing cutting, what should be done? On Q2 itself, as soon as you read Z naught from the stack, you will read nothing from the tape. You will push Z naught onto the stack, or you can push nothing also. That means stack can be empty or non-empty. It hardly matters, because we are doing it by final state. So we will jump to Q3 state, which will be our final. Okay, I hope I have made the point clear to all of you. So this is very, very simple PDA, and which is accepting what? A power 2 and B power n. Okay, so let me put everything on one side so that you can note it down carefully, and we will jump to next question. Okay, please pause the video and watch and write all these, take notes. Please pause the video and take notes. I am jumping to next slide. Next is A power 3n, B power 5n, n is greater than equal to 1. Construct PDA accepting L. So this is again a simple question. A power 3n, B power 5n. See, if we have A power n, B power 5n, what should we do? We will write this A and make 5 A's and push down to the stack, so that cutting becomes easy. Now problem is we have 3 A power 3n. So A's are multiple of 3. So what should be done? So first A, we will make 5 A's and push down to the stack. Second A will be ignored. Third A will also be ignored. And then fourth A, we will make 5 A's and pushed onto the stack, and so on. Okay, so first A will be pushed onto the stack by making 5 A's. Second will be ignored, third will be ignored, and then fourth will be pushed onto the stack by making 5 A's, and so on. Okay, so we are looping in these 3 states only. Okay, so Q naught will do all these things. That way it will make 5 A's. Q1 will ignore. Q2 will also ignore. Okay, we are changing state because we have to keep count of how many A's are ignored. Okay, Q1 on remaining Q1 only, we cannot ignore the A's, because then we will not have count on how many exactly A's have been ignored, and so on. I hope I am making sense to you. Okay, and let me do it properly. Okay, and you can visualize it like this also. A power and B power 5 and and we can visualize it like this also, a power 3 and b power n. So what will you do? What will you do? We will push first a and ignore two a's. So first a will be pushed now, but we need b power 5 now. So first a will become 5 a's and next two a's will be ignored and so on. Okay, I hope I have made the point clear. So now let me design PDA very easily. I hope you have got the logic. So what will we do? On Q naught, as soon as A is read, Z naught is read from the stack, A is read from the tape, we will push A power 5 Z naught onto the stack. Then we will jump to Q1 stage. What is the work of Q1? Q1 will read A from the tape and A from the stack. It will push single A because we have read this A after popping. We will push it again and we will ignore this A. Now on Q2, Q2 will be doing exactly same thing. Okay, that means it will push this A because it has been read after popping, and it will ignore this A. Now next A we will make 5 A's now. So that is the duty of Q naught. So we will jump to Q naught from Q2 like this. Okay, so on Q2, you can say first A we have make 5 A's, second A is ignored, third A is ignored, and then fourth A should be again, it will be converted to 5 A's and pushed onto the stack. So that means what we should move to Q naught itself. Okay, so now we will apply move A. What should be right here? Please pause the video and try to answer it yourself. Okay, so see here, we have to push this A because we have read it after popping, and we are making 5 A's for this A. So total 6 A's should be pushed onto the stack. Okay, please listen it carefully, otherwise it will trouble you a lot. So A power 6. I hope I have made the point clear to all of you. So now we have directly indirectly we have managed all the A's. So it's your homework. Okay, try to you can say accept string by this PDA. Okay, and actually it's not yet completed, but you should try for A's. So you should be getting A properly balanced, or you can say number of A's in the stack that will be equal to number of B's on the table. This is our aim. With the help of this, these three states, we are able to do it. Now, who will read the B first? Obviously, Q naught will read the B. And same logic we have, as I have discussed here also, same logic will be applied here. Q naught will read the B, or if you are not able to follow, I will do one working example for you also. So B A, then null, that means nothing will be pushed onto the stack, so that means cutting will be started. On Q3, what we are going to do, B A null, that means what we will do, cutting. After cutting, we are at Z naught. Okay, oh sorry, from the stack we have read Z naught. We will read nothing from the tape. Okay, and there is your choice that you put Z naught or push nothing on the stack, because we are not concerned with stack, we are doing it by final state. So we will jump to final state, that is Q4. Okay, now let me trace small example so that you get a clear cut idea about it. A power 3 and B power 5 and now, so 1 2 3 4 5 6. A power 3 and matlab number of A's should be multiple of 3, and B power 5 n means what? 1 2 3 4 5 6 7 8 9 10. Okay, A power 3 and B power 5 n. I hope I have made the point clear. Okay, so now let me trace it for you. So what we are going to see here, initially we have Z naught and we are at state number Q1, sorry, Q naught. So Q naught A Z naught, see here, move A power 5 Z naught. So Z naught will be pushed and 5 A's will be pushed onto the stack, 1 2 3 4 and 5. Now we are at Q1. Q1 will ignore this A. Now we will jump to Q2. Q2 will ignore this A. We will jump to Q naught. Q naught will make this A as 5 A's. So 1 2 3 4 and 5 A's. Now we will jump to Q1. Q1 will ignore this A. Now we will jump to Q2. Q2 will ignore this A. Now we will jump to Q naught. See here carefully, Q naught, Q1, Q2, Q naught, Q1, Q2, and so on. So obviously state will be Q naught on B. So see here carefully, B A null. So that means what we are doing, cutting. Now you will do cutting and so on. After cutting, so you will get Z naught, because here 10 B's and here 10 A's. Okay, so let me do it faster, in a faster manner, so that you do not get confused. Okay, keep on cutting them. Okay, so this is the power of TOC. I am not counting them, I am just simply cutting them. So we have done cutting itself, and there were 10 A's here, so and there were 10 B's here. So we have done cutting, everything is fit and fine. Now we PDA will be at this state. Okay, PDA will be here and state will be Q3. So on Q3, as soon as you read Z0 from the stack, you will read nothing from the tape, and you will push Z0 onto the stack, and we will jump to Q4 state. So I will cut Q3 and I will put here Q4, and Q4 is our final state. And what I will say, starting from initial state, see here carefully, starting from initial state, we have read the entire string, and PDA is at one of the final state, and string will be accepted. Okay, so this example I think have made the concept crystal clear to all of you. So let me do it, put everything on one slide so that you can note it down carefully. Please note it down carefully. I am jumping to next slide. See here, a power n, b power m, n is greater than m. Construct PDA accepting L. Okay, try to construct PDA which will accept this, say this L. So n should be greater than m. What is the basic meaning here? N should be greater than m means what? N should be strictly greater than m. Now, sorry. Yeah, n should be strictly greater than m. So what does this mean? They cannot be equal. So language will have what kind of string? Single A will be accepted. Why? Because n will be 1, m will be 0. 1 is greater than 0, so single A will be in the language, or it should be accepted by PDA. Similarly, double A, triple A, and so on. Null will not be in the language because null means what? A power 0, b power 0. So m and n are equal, hence null won't be present. Now next will be, say, double A B, or triple A B, or triple A double B dot 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 dot. That means what? Number of A should be more than number of B's. That's it. So how will you construct PDA for this? Okay, so let me show you carefully. See what we are going to do here. So on Q0, initially we are at Q0. Okay, so no matter how many A's you have read, only A's should be accepted now. So what I will say, see, because null is rejected, try to follow here carefully. Null is rejected. Null is rejected, that means initial cannot be final. Okay, but only A's are accepted. So what I will say, A Z0, A Z0, because the way will be similar. Na? Number of A's should be greater than number of B's. So we will push all these A and we will do cutting with the help of B. Okay, and after doing cutting, what we should say, A should remain in the stack itself, and string should be we should have read the entire string. After reading entire string, we should have A's in the stack itself. If we have A's in the stack itself, that means what? Number of A's are more than number of B's. This is obvious thing. Okay, so how exactly we are doing it? Now I'm showing you. A Z0, we will jump to Q1, and Q1 will be our final state. See here carefully, why Q1 will be our final state? Because single A should be accepted. Please note it down carefully. Single A is accepted, and A Z0 means what? A Z0, so we should be at final state. Now, only A should be accepted now. So we will have a self loop here. A double A. So we will keep on pushing the A's onto the stack itself, and after doing after pushing A's only, and we are at final state, and string is an entire string is read, we will say that string should be accepted. So we have a self loop of A on the Q1 itself. Now, as soon as B start coming, we will move to new state. That means B A null. We are doing cutting. We will jump to Q2, and Q2, what Q2 will do? It will do cutting. That means B A null, it will cut, do cutting. And after cutting, what should we say? We should say on Q2, we should read nothing from the tape. As soon as we should read nothing from the tape, okay, and A from the stack, okay, it's our you can say choice that what we are going to push in here, and we will jump to Q3. Q3 will be our final state. Okay, so now you will get confused when, see here, on Q2A combination, see here carefully, Q2A combination, we have true move with the help of B, and we have a null move. Hence, it will become what? NDPDA. It will become NDPDA. So here we have a choice now. We can put A also, we can put null also. So the main thing is we have designed NDPDA. This is not DPDA. So how to design DPDA? There is no way out to design DPDA. The only way is you should be able to get proper idea when string is going to end. So this idea can be given by end marker. So let me introduce the concept of end marker. End marker. End marker means every string will end by this special symbol called end marker. Every string is assumed to be terminated, is assumed. This is our assumption. Okay, that's why I'm saying it assumed, is assumed to be, every string is assumed to be terminating or terminated by special symbol, called end marker. Okay, you can write it here. I am just saving the time. Special symbol called end marker, and different books have different notation for it. So my notation will be this symbol. Okay, this will represent end of string, and it's logical also. String is you can say coming, and this is a wall, okay, which is saying that stop. Now there should be no symbol ahead of it. So this is how I have given you a just small logic. Okay, so please, so obviously this is not the case, but I'm just showing you how to why or you can say a simple logic that why we are using this as a end marker. Okay, so different books have different end markers, and I'm using it. And logic I have shown you. Of course, it is not a proper logic. I have just shown you. Okay, or just I have shown you the way to remember that this is our end marker. Okay, now everything is fit and fine. I will say here, null was creating problem na, null was creating problem. So now I will write here, this end marker. End marker will give you idea about when string is going to be ended. And every string, please see here carefully, every string is assumed to be terminated by special marker, a special symbol called end marker. So here, if we have string of only A's, then we should have end marker also. Okay, so end marker A, and there is your choice. Yeah, you want to push A or you push nothing and so on. So let me say I am pushing nothing onto the stack. Okay, or let me do it properly, or let me take another color so that you do not get confused. End marker A, and we are going to push nothing onto the stack. Okay, so this move we have to add, and why I'm adding it, so let me give you some idea. If string is the double A, so after double A we should have end marker, because it will show you end of string. So double A na, so see, try to trace here, q naught az naught q naught aa double A. So we have consumed these two A's. Now you should have end marker, so end marker A null. Okay, so this will show you properly that we have string of only A's, and that string also should be accepted. So q1 is final. Now as soon as you read a B, then B and null, that means you do cutting. You will keep on doing cutting, and after cutting you read the end marker. That means what string is completed, and you should be able to read A from the stack, and you will push push A on the stack itself. And it's our own choice. You should push A on the stack or Z naught. Sorry, Z naught we cannot push, or you can push nothing onto the stack also. Okay, so we have choice. Whatever we want, we can push. Okay, so I hope I have made the point clear to all of you. Okay, so let me take one example so that you get a crystal clear idea. Okay, so let me take a string, say triple A, triple B, and marker. What will be done here? See, we are going to push all the A's. Initially we have Z naught. All the A's will be pushed onto the stack. Whenever B come, we will do cutting. We are doing cutting. Who is doing cutting? Q2 is doing cutting. So finally Q2 will read end marker. But okay, we are at Q2 now. So Q2 will read this end marker, but it's reading Z naught from the stack. If Z naught from the stack is read, that means what number of A's and B's are equal. This will give you guarantee na, that number of A's and B's are equal. Why? Because we have read end marker. That means what string is ended, and that means what, B's and A's are properly cut. That means what, A's and B's are equal. Okay, but it should not be the case, because n should be strictly greater than n. Na? So hence the move should be like this: Q2, okay, Q2 and marker Z0. This move is missing. See here carefully, we do not have this move. Okay, and we have this move now. This means what, we have an entire string, still A is left in the stack. That means what, number of A's are more than number of B's. I hope I have made the point clear to all of you. So let me put everything on one slide so that you can note it down carefully. Okay, please note it down carefully. I am jumping to next slide. W hash W transpose, W belong to AB star. Okay, so try to construct PDA. Okay, I have not written, but try to construct PDA here. So what will be the logic? W transpose, W belong to AB star. So this is palindrome, or you can say hash palindrome. Why I'm saying it as hash palindrome? Because hash is in between the two. You can say W and W transpose. So hash will give idea when to start cutting. Okay, let me show you an example. Double A B hash B double A. So what should be done? Initially we have Z0. We will blindly push each and every symbol. A will be pushed, then this A will be pushed, then this B will be pushed, and as soon as hash is read from the tape, we will ignore this hash, but state will be changed, and that state will do cutting. So how cutting will be done? B and B cut, A and A cut, A and A cut. Okay, so now we are here, and where exactly we are, we really do not want to see what exactly symbol is present. I will say simply that we have read Z0 from the stack, then we will read nothing from the tape, and we will jump to final state. So I hope logic is crystal clear to all of you. So see here carefully. See, if we have a string like this, triple A B A hash, reverse of this string will be after hash, na? Reverse of this string will be A B triple A. Okay, so now see here carefully. Initially we have Z0. So when we are pushing the symbols, when we are pushing this onto the stack, we will push in the sequence na triple A B A. And when we read this string, this is nothing but W transpose, because we are popping from here itself. Now last in first out. So whatever symbol is last pushed, it will be pushed out first. Sorry, it will be popped out first. Whatever symbol is pushed last onto the stack, it will be popped out first. So directly, indirectly, what I'm saying is we have W transpose here, and here also W transpose. So each and every symbol must be matching. That means AA, then BB, then AA, then AA, and then AA. Okay, so I hope I have made the point clear. So the logic will be whatever A or B's are coming, you will push them blindly. You will push them blindly, and then as soon as hash come, the state of mind will be changed, and we will start cutting. So let me do it properly. Now let me design PDA. On Q0, that is your initial state. If you read A Z0, then A Z0. Okay, but so this means what, string is starting with A. String can start with B also. So see here, B double A hash AAB. So initially we will have Z0. So B and Z0. Where is the move? So you have to keep here also. Okay, so we will put B Z0, B Z0. Now anything can come, na? So we will see. We will blindly push, na? So AA double A, double B, BB double B, AB, AB, BA, BA. So why I have written these moves? See here carefully. It's homework for you. Try to analyze from here itself. See, A was pushed onto the stack. Next A was pushed onto the stack. So when next A came, then we are reading this A from the stack and this A from the tape. So AA move should be present. Similarly, AB, BA, BB, and so on. Each and every combination should be present. So I have put each and every combination. Now hash will be read from the stack. then sorry, hash will be read from the tape. Then obviously we can have A or we can have B also, na? Okay, we can have A or we can have B also. Why? See, and we will push this A or we will push this B onto the stack. That means hash will be ignored and we will jump to Q1. Now, how I am writing this? See here carefully, hash A or hash B. Hash A means what? After we have read hash from the tape, but from stack we can read A also and B also. This is very simple scenario. See here, we are reading hash, then we are reading this A na. So hash A combination and hash B combination also. Okay, I hope I have made the point clear to all of you. So this A is what? Last symbol of W, and this B is what? Last symbol of W. Okay, so last symbol of W is A, then we will push this A onto the stack. Last symbol is B, then we will push this B onto the stack. Now finally, what we are going to do, we are doing cutting on Q1. So cutting, how cutting will be done? We should read A from the tape and A from the stack, then we will push nothing onto the stack. We will read B from the tape and B from the stack, we will push nothing onto the stack. So we are doing cutting, and after doing cuttings, okay, after doing cuttings, what should be done? See, there should be, we should read nothing from the tape, Z0 from the stack, and we will push, it's our own choice, put Z0, push null, and so on, whatever you want, you can push. So let me push null. Push null is indirectly saying that nothing is pushed onto the stack. You already know this. So we will jump to Q2, and Q2 will be our final state. Okay. I hope I have made the point clear to all of you. So this is you can say PDA for this language. Okay, and I hope you already know by now that in CFLs also I have shown you. This is what, yeah, I have already written hash palindrome. Palindrome means string is same whenever we are reading it from left to right or right to left. Okay, so let me give you one idea. Double A B hash B double A. So read this this palindrome from here or here. So read from left to right or right to left, we will get the same string itself. Okay, so hence we have designed PDA for hash palindrome, and see here carefully, it is DPDA or NDPDA. This will be DPDA. Why DPDA? Because we have only one null move, that is null Z0 null, and Q1 Z0. With Q1 Z0 combination, there is no true move. Hence it is first class DPDA. Now I'm jumping to next slide, that is WW transpose. Okay, from here I will see this is homework for you. Try to construct PDA for it. Okay, and if you are not able to construct, obviously I will show you in the next class itself. And I am giving you a hint that DPDA is not possible here. DPDA is not possible here because we cannot say when one string is ending and when next string is starting. Like double A B B A. You will say whenever B is coming after B, that means what? We will start cutting. But this is not the case always. So if the string is like this, now what can you say? After A we have A, and again after this A we have A, and after this A we have A. So when will you start cutting? Okay, so obviously after this B double A we will start cutting. But how PDA will know? PDA is not having eyes. We being human, we have eyes, but PDA do not have eyes. So PDA cannot, DPDA cannot do. Okay, so we will take help of non-determinism here, and we will construct NDPDA for it. Okay, so please try to remember, we will not be able to construct DPDA for it. We will not be able to construct DPDA for it. Okay, so rest everything I will cover in the next class itself. Thank you so much. Bye bye.